and thank you for joining. My name is Pavlo, and I would like to talk about automated migration to Bazel with Airin. So Airin is an open source framework that allows you to automate the migration of your projects to Bazel build system. And you can find this project on GitHub. It's available by the link on this slide. And overall, it consists of two primary components. So first of them is a Starlark Template Engine. And basically, this is a code generator for Starlark that allows you to define some templates using Kotlin language and Kotlin DSL and generate Bazel scripts based on those templates. And the second component is a migration component, which works as a plugin to your build system, and it gathers all the build configuration of your project and generates corresponding Bazel files using a template engine. If you want to learn more about the project, please feel free to check out the blog post, and the links to it you can find on your screen. But before actually considering the details of the migration flow, let's think why we would even need to automate the migration. So basically, imagine working on a large project that consists of million lines of code, has hundreds of modules, and is being maintained by hundreds of engineers. It would be really hard to manually create all the Bazel scripts for such a project because you also need to expect constant updates into the build configuration of your initial build system that are done by your teammates who are doing some product work. And it's important to understand that the migration of large projects to Bazel does not happen overnight, but it happens gradually. And this means that during the migration, you would have two active build systems in your project. And moreover, the first one, the initial one, would be the source of truth in this case. And therefore, it's important to have a quick mechanism of regenerating all the Bazel scripts in your project after any update to the configuration of, the builds of initial build system. And here is one Airin can actually help you. So how does it work? It starts all with the initial build system. So the migration component from Airin gathers all the build configuration from your project, and this can be the list of modules in your project, the list of dependencies for each of those modules, and many more properties. And based on that, it can generate the corresponding Bazel scripts with using a Starlark Template Engine. And when it comes to the supported build systems, initially Airin supports Gradle build system, and this also means that it supports migrating Android projects. And the integration is done by using a Gradle plugin. But it's not limited with it, because Airin is extensible enough that it can support other build systems, for example, Maven, or even moreover, it can support Xcode and other build systems. But you may ask, so how does all of this work together? Because Gradle and Maven are written in Java, while Xcode is written using languages such as C or Objective-C. And the answer is Kotlin multi-platform. Airin is written in Kotlin language, and it leverages the powerful feature of that language, which allows it to be compiled to different platforms. So the core migration component of Airin is built as a Kotlin common module. And this means that it can be available to all platforms. However, when it comes to Gradle or Maven build systems, they are being built as Java modules. And therefore, those components have access to Java SDK and to specific APIs of those build systems. And the same way, integration with Xcode can be done. While Kotlin native can be compiled to the native binaries, it can interact with the C code, and that's how it can provide support for Xcode. So at this point, Gradle is already supported, while support for Maven and other build systems is being developed. And now let's dive deeper into the Starlark Template Engine and see how it can help us to improve the code generation process for Bazel. So it follows three primary goals. So the first one is it must provide a declarative code generation. This means that all the code that describes the code generation must be as similar as possible to the actually resulting ending generated code. Moreover, it must provide a typesafe API for the code generation. This will prevent many errors during the compilation stage on a Kotlin site. And moreover, it must be available as a standalone component. This might be useful in cases when you don't need all the migration logic, but you just want to have a lightweight tool for convenient generation of Bazel scripts. And this can be done with Airin. And the code generation overall happens using template. So for example, imagine you have a large project that has like hundreds of Java modules. Most likely, Bazel scripts for those hundreds modules would have a lot in common because all of them are using like Java rules and pretty similar configurations. And by using templates, you can define the general skeleton for all of those modules while having placeholders for unique data for those modules. For example, you can see that this is a valid code, and those placeholders can be filled in with the variables, just regular Kotlin variables. And when we are using the template from the previous slide, we can generate multiple build configurations, Bazel scripts from it for multiple modules. And they will be pretty similar, but their unique details would be different. For example, for module A, we would have a unique name of the module A, and also we would have a list of dependencies that is applicable to module A. And the same can be done with module B and like many other modules. And now let's talk in more details about some advanced and more complex Starlark scripts. And let's see how Airin can generate code for them. So in this slide, we can see that we have a list comprehension that for each file in the list of files, it would create a target using general. And as we can see, this code uses slice expressions and also concatenations. And let's see how it can be generated using Airin. So here you can see the valid Kotlin code and the usage of DSL that Airin provides. So let's see in details how it works. So first we can define and generate the variable assignment. And it's important to note that this SFC files list would be the type of list of strings, which provides a type safety. So next we can just use regular Kotlin function for using a general and like define different calls to rules. And it's important that we can have slice expressions. Moreover, we can have concatenation expressions. And as you can see, we have also type safety still preserved. So the name expects the type string. And if any other type would be provided, so the Kotlin code would not compile. And the same works with out, which expects the list of strings. And all of that is wrapped into the DSL that generates the list comprehension. And basically the file argument in the Lambda corresponds to the item type of the list that we are working in. And again, it preserves the type safety of the API. And now when we saw how the code generation works, let's see how actually Airin can be used to migrate your project to Bazel. And in this example, we would see how we can migrate Gradle project to Bazel. It all starts with defining a template for your modules. In this case, we define template for all Java modules, and this can be done using just regular Kotlin function. And we can pass arguments that are applicable to specific modules to that functions. It's also important to understand that this code that we define here should not be available to the source code of the application, but it must be available to the class path of the build scripts. And in Gradle, this can be done in many ways, but the simplest one is to use a build src directory. So you can define this directory in your project and write all the code there, and Gradle will treat it in a specific way so that all the code would be available in the class path of the build scripts. So next, we must introduce one more entity, which is called template provider. So the goal of template provider is to map your template to the right type of modules in your project. So for example, we've just created a Java template, and this template provider would assure that those templates would generate code only for Java modules. And this can be done by implementing two functions. First of them is canProvide, which actually takes the module, the Gradle module, as an argument, and it checks whether it has Java plugin applied to it or not. And when we check that, we need to implement the second function, which is called provide. Basically, the goal of this function is to take the template that we've just defined and to fill it with the correct data that is specific to this particular module. And it's important also to understand that in Gradle, we have such entity called project, but in fact, it means that it represents the Gradle module. So please don't be confused with that. So in this case, this function would be called for each Gradle module in the project. And for each of them, we would retrieve the specific data from that module. For example, we can have the name of the module, and we also can retrieve the list of dependencies that is used in this module. And this is how it can be done. And finally, we just need to register this template provider in our project. And this can be done in the root build.gradle file using the DSL that Airin provides. So we can register this template provider, and we can register many more. So for example, we can have a specific template for workspace files, and we can have them as many as we have different types of modules in our project. So once all of this is done, we can just trigger the migrate to Bazel command, and this will allow us to start the migration and generate all the build scripts. And this process can be done iteratively until you have all the templates created for all the types of modules in your project. And this is how it can help you to automate the migration process. So you can find this project on GitHub, where you can find like more documentation and some examples of how this can be migrated. So overall, now the Gradle support is already there, and Maven and support for other build systems is being developed. That's it. Thank you for watching.